So the sum and difference of cubes has an excellent formula that we wash with soap, the acronym. So the idea here is that whenever you have a sum or a difference and you see something that's raised to a third power or divisible by 3, we'll see later in subsequent problems, you can do the difference of squares or difference of cubes or sum of cubes. And so the formula is a cubed plus or minus b cubed. I'm going to put both formulas here together in one place, and that's equal to a plus or minus b times a squared minus plus ab plus b squared. Now, this formula, like I said earlier, we wash it with soap, where this acronym is this sign right here is the same sign. This sign right here is the O, opposite sign, and this last sign is AP for always positive. So we say soap, same, opposite, always positive is what the SOAP acronym stands for. And so what that allows me to do is to focus on these signs right in the middle here, where this is a sum on my problem. So I focus on every sign in here will depend on what this first sign was. So if it's a sum, then we stick and tag along here at the top. This will be a plus sign, the same sign. This will be the opposite sign. And this last sign is always positive. Doesn't matter what the first one was. If we started with a negative sign, then this next one would say we'd stay the same, and then this next one would be positive, the opposite, and then this one would always be positive in the back. So that'll change depending on how the original problem was set up. But first thing we want to do is figure out that these are indeed cubes. Now what cubes are numbers that you can raise to the third power to get the coefficient or variable we're looking at. And cubes would be like 1 cubed, 2 cubed, 3 cubed, 4 cubed, 5 cubed, etc. And so the numbers we're looking for are 1, 8, 27, 64, 125, etc. These numbers are cubes. And so when we recognize one of these numbers, like in this case, the 27, then we know that something cubed produced that number. This 27 is actually 3 cubed. And this d is being cubed, so it's d cubed. So we can say that this is a sum of cubes. And this will add to our second layer of factoring completely, where we have two terms, binomial. And whenever you have two terms, it's either the difference of squares or the sum or difference of cubes, or we can't do anything with it. So in this case, it is the sum of cubes. So we can rewrite this to be, notice this is AB, and then b squared. We're just going to line things up underneath here. So this, I'm actually going to bring this problem over here. So this is my 3 cubed, and this is the plus version, and then d cubed. And so what we do is we just replace everything that is an a or b with my numbers 3 or d. So this is going to be equal to parentheses 3. We're going to keep the plus sign, same sign, d, and then this will be 3 squared. And then we do the opposite sign, so minus. And then AB is you multiply the two terms together, 3D. And then we do always positive, and the last term is D squared. Now, you do want to do one layer of simplifying because you don't want to leave a 3 squared there, that's 9. The reordering, it doesn't matter, but we could reorder it. I'm going to leave it alone for now just to leave it in the same order. So this is d 3 plus d times 9 minus 3d, and then plus d squared. So that's my one layer of simplifying. I don't really like that it's not a descending order, but this will work as my answer. If I wanted to have more descending order, I could, but this will be sufficient for my answer. I could put d plus 3 and then times. I could just rearrange the d squared minus 3d and then plus 9 in the back would also work. But either one, this will work up here. We'll try another one. All right, in the second example, we've got a coefficient with our variable. So we've got 8c cubed and then 125. 125 is 5 cubed. 8 is 2 cubed, and c is cubed. So I'm going to write this together as 2c with parentheses cubed to recognize that it's the whole term cubed. So we do have the sum of cubes here. So a plus sign between them. So our formula says you write the two terms the way they are, 5 and 2c, and then you write the first term squared. You multiply the two terms together, 5 times 2c. Notice I'm not actually writing the formula out this time. I'm just telling you what it's saying to do, and then the last term gets squared. So that's how the formula works. It's first term, last term. So it's AB, A squared, AB, B squared, if you were to have it written out in front of you, which I hope you wrote it from the last slide. But the point is once you get this all written out, this is like the skeleton of it. Now you just fill it in with the SOAP acronym. The SOAP acronym says this sign should be the same as what you started with, plus sign. This next sign should be the opposite sign. And the last sign should be positive. Now you just have to clean it up, and clean it up being like actually square the 5. So if I was to finish, I'd just say 5 plus 2c, and I'm not going to rearrange it at the time. I'm going to leave it alone. And then 5 squared is 25, and then you multiply this together. It's going to be negative 10c, and then plus, oh, I didn't put a square on that, 2c squared. So that should be 4c squared. When I say squared, you have to distribute the square to both of those. So it's, again, that first term should have been squared, and then multiply a, b, and then last term squared. I don't know why I said it. I don't know why I didn't put the last term squared. So this is my final answer down here. You could rearrange it if you like to be in descending order. The last time I did, this time I'm going to leave it. So we're going to up the rigor a little bit more here. We've got more variables and more powers, more coefficients. So we've got 64, t cubed. 64 is 4 cubed, and t cubed is t to the third. So I'm going to say 4t to the third is my a value, the first term that's being cubed. And then minus 125 is 5 cubed, and then s cubed is just s. So 5s to the third power is my b value, the second term. Now this is my first difference example. And again, we're going to do that skeleton. The bones of it is just you write your first term, the 4t, and your last term, your a and your b value, 5s. And then you say times, we're going to write 4t in parentheses, and it's going to get squared. So it's first term squared. And then it's the product of the first and last term. So you write 4t times 5s. And then it's your last term squared, 5s squared. Now, that's the skeleton of it. That's the bones of the formula. So it's a squared, b squared. And then we just need to fill it in with SOAP. And again, the SOAP acronym stands for same, opposite, always positive. So this is the same sign. We start with a minus sign, so we just put a minus sign in there. And then this second one is opposite. So we had a plus. The opposite is, we had a minus. The opposite is plus. And then the last one is always positive. So we put a plus sign in the back. So minus, opposite, always positive. So this is the correct form. And then all we have to do now is just simplify correctly. And this is where students struggle because we got like a square there. We got to square the 4 and the t. So 4 squared is 16. And then t squared is t squared. Plus, you got to multiply the 4 and the 5 here to get 20. And then ts. And then we've got 5s squared. So the 5's got to get squared and the s has got to get squared. So we say plus, and then we got 25s squared. Then we close parentheses around that and just bring our 4t minus 5s down. And we should have our fully factored polynomial down here. That was the difference of cubes, and now it is a very long factored expression.